subscribe.
Hey y'all, welcome back. So today we're going to be working on these algebra problems, and for at least the first few I'm going to let a good friend of mine go through and show you how to work out problems 1 through 8, and then I'll close it out with the systems of equations problems at the end. So here, let's go ahead and start with number 1.
In this problem, we want to determine the slope of the line passing through these points given here in A, B, and C. So let's first start over here at A. So here we're given the point -3, -7, and then 5, -2. When we find the slope of a line, we're always going to use the formula y2 minus y1, and then we're going to divide that by x2 minus x1. And you may know this as the change in y divided by the change in x. So when we look at these points up here, we need to figure out what's y1, what's y2, what's x1, what's x2. So we pick a point here, so -3, -7, we're going to make that x1, y1, and then we'll make 5, -2, the x2, y2. So let's take the -2 from over here, and then we're going to subtract this -7 right here. And then we're going to divide by, since we started with the -2 here on the y's, we now need to start with the 5, and we subtract this -3. So it's 5 minus -3. So this gives us really plus, right? So it's -2 plus 7, which is going to give me 5. This is 5 plus 3, which is going to give me 8. So the slope of the line containing those 2 points is 5/8. Now let's look here at B. Same idea, we want to find the slope between 2 points. So we are going to use y2 minus y1 is divided by x2 minus x1. And then we choose our points. So we can say this is x1, y1, and then this could be x2, y2. So in looking at this then, we can take the y-coordinate here, 5, subtract 2. So this would be 5 minus 2 divided by, now since I started with 5 as the y-coordinate here, I do have to start with the -3/4. That's its corresponding x value. And then I subtract the -3/4 from here. But when we do this, what we see is we end up getting this to be 3. And this number here is 0. I don't have a defined number when I have a non-zero number in the numerator, but 0 in the denominator. So this slope is not defined. Or we say that it is undefined. And just for a little bit of further understanding, what this means is that you have a vertical line going through these, right? So if we were to go ahead and plot this, let's just plot it real quick right here. You're going to be left -3/4 and then up 2, so maybe a point like here. And then you would be left -3/4 and up 5. So you see that these 2 points are stacked on top of each other, which gives us a vertical line here. That's what's making this slope undefined, because it's vertical. If we look over here at part C, we're given 2 points again. We want to find the slope, so we're still going to use slope is y2 minus y1 divided by x2 minus x1. We choose our first y-coordinate, so we're going to do 3/5 minus 3/5. And then we're going to divide that by, since I started here, I'm going to start with the -1/2 in the denominator minus 1/2. So it's -1/2 minus 1/2. 3/5 minus 3/5 is 0. And -1/2 minus 1/2 is -1. And 0 divided by -1 is 0. So this is a flat line. This is a horizontal line that is actually going through 3/5. So these are the 3 slopes for the given points that we have. In this problem, we want to write the equation of the line which passes through the point 412 and -5,6. And we're going to write it in point slope form, slope intercept form, and then standard form. So if we have to write an equation of a line that passes through 2 points, we need to find the slope of that line. In order to find the slope of the line, we're going to take y2 minus y1 and divide that by x2 minus x1. When I look at my 2 points here, we can, it doesn't matter which one you call x1 and y1 and which one you call x2, y2. It matters that you have them paired up correctly. So I'm going to call this one x1, I'll call that y1, pair those up, and then I'm going to call this one here x sub 2, and then this one would be y sub 2. So putting those now into my slope formula, we will get 6 minus 12 divided by negative 5 minus 4. 6 minus 12 is a negative 6, and negative 5 minus 4 is a negative 9. So when I simplify this, then the negatives will become positive, right? And then 6 divided by 9, if we divide by 3, you're going to get 2/3. So we know that the slope of the line going through those 2 points is 2/3. Now let's go ahead and write it in the equation of the line, rather, in point slope form. So point slope form means that you have a point and a slope. So it is y minus y1 is equal to m times the quantity x minus x1. This is your slope. And then the point here is your x1 and y sub 1. So when I use what we have over here, we know our slope is 2/3. So we're going to get y minus y sub 1, which we used as 12 over there, is equal to 2/3 the slope times x minus x sub 1, and x sub 1 over there we said is 4. So this is the equation of the line in point slope form. Now let's go ahead and write the same equation, or the same line going through these 2 points, but now let's do it in slope intercept form. So with slope intercept form, that is y is equal to mx plus b. This is still your slope, so that's the slope part of slope intercept form. And then the b is where the line crosses the y-axis. So this is actually the intercept, and it is the y-intercept. Okay, so there's a number of ways that you can do this. You can use your point slope form, distribute the 2/3, and then add 12, simplify, and you can get it usually then in slope intercept form. So I'll leave it to you to try it that way. What I'm going to do is take the slope intercept form with one of these 2 points here and solve for b, so that you see maybe a little bit different way that you can handle this problem. So what do we know? I know my slope is 2/3, and then I'm given 2 points up here that are on this line. You can choose either point and substitute the x value in for x and the y value in for y. Then you will solve for b. So let's go ahead and use this point over here this time. So I know that my x value is negative 5, so I'm going to put that here. And my y value over here is 6. So that's going to go over here where the y is. And now my only unknown quantity here is b, the y-intercept. So let's go ahead and solve this. So we would get 6 is equal to negative 10/3 plus b. To solve for b, we add 10/3 to both sides. So 10/3 plus 6 is equal to b. And now I'm going to go ahead and get a common denominator and add them. So 6 with a denominator of 3, that's going to be 18/3. And then I'm still adding the 10/3 to that. So what I find out here is that b is equal to 28/3. My y-intercept, or the y-intercept, is 28/3. So written in slope-intercept form then, the y equals mx plus b, we're going to get, I'll write it right here, y is equal to 2/3, which is our slope, x plus b, which we found to be 28/3. So that is the same line written in a different form. It's written in slope-intercept form. It tells you a little bit different information than this one did. But again, you could distribute this 2/3, solve this for y, and you should still get this answer over here. All right, the last form we need to put this in is standard form. Okay, and standard form is ax plus by is equal to c. And if I just study this form, we see that on the same side of the equation we have our x term and our y term, and then isolated on the other side of our equation is our constant term. And one important thing about standard form is that a, b, and c have to be integers. Okay, and by integers, I mean if we look at a number line, right, here's 0, here's 1, 2, 3, and then back this way is -1, -2, -3, and this continues on. But the integers are these numbers here. Okay, some might say it doesn't include decimals. I think that's a little tricky terminology, so it's the whole numbers and the negatives. All right, so when we want to do this now, let's go ahead and take this form that we have right here. We can take our slope-intercept form. I need to get my x term and y term to be on the same side of the equal sign and my constant term isolated by itself. So what that means is I'm going to I'm going to subtract this 2/3 x from both sides of this so that I get a -2/3 x plus y is equal to 28/3. Okay, now let's look at this. So I've got my x and y term both on the same side of the equation. The constant is isolated on the other, but I don't have integers right now. So in order to get this to be integers, I need to multiply through by a value that's going to clear out my denominator, if you will. So in this case, I'm going to go ahead and multiply everything in this equation by 3. So I'm going to take the 3 times the -2/3 x. That's going to give me a -2x because 3 divided by 3 is 1. I take the 3 times the y. That's going to give me 3y. And then please don't forget, you've got to take this 3 over here. You've got to multiply the whole equation to preserve this equality. So 3 times 28/3, the 3's, 3 divided by 3 is 1, right? So we just get left with 28 over here. Now this is in standard form. So that is the equation of the line that goes through these points written in 3 different forms. In this problem, we want to write the equation of the line which passes through the point -2, 31, and has an undefined slope, and we want to write that in 3 different forms: point slope form, slope-intercept form, and standard form. So first of all, let's just get an idea of what we're dealing with here. So I'm going to sketch a little graph of what we might have for a line. So I know it's going to go through -2 and then way up here at 31. So here's the point -2, 31. All right, and what we want here is this undefined slope, right? So we want the undefined slope. What that means is we need this to be a vertical line. Okay, if we have an undefined slope, that means that in the denominator, when we did the change in y over change in x for our slope, it means that the denominator was 0, which means there's no change in the x values. The x values are staying constant. That's what this tells me when it's 0 in the denominator, and therefore gives me an undefined slope. So that means I'm not deviating at all to the right and the left from -2, right? So the line would look like this. And then this has the equation x equals -2. And that's the equation because no matter what point you plot on here, the x coordinate of any point is always -2, right? The y values are changing, but the x values are staying constant at -2. The other way I like to think about this is that this vertical line cuts through the x-axis at -2. That helps me remember that the equation is x equals -2. Okay, so now if we start to put them in these forms here, so let's just look at point slope form. Okay, point slope form is y minus y1 is equal to m times x minus x1, where the point it goes through is x1, y1, and m is your slope. Well, I have a little bit of a problem here because my slope is undefined, meaning I don't even have a number that I can put in for this m. So this is not applicable. To this, or we might say this just does not exist in this case. So I can't put a vertical line, the equation of that, in point slope form because the slope doesn't exist. All right, well, now you may be thinking, if we're trying to do that for slope intercept form now, right, and slope intercept form, remember that, y equals mx plus b. Am I really in any different of a situation here? I still have to have a slope in order to write it in slope intercept form, and I don't. There's no defined number that can give me that slope. So this, I cannot write it in slope intercept form. Doesn't work because I don't have a slope. It's undefined. When we look at it in standard form, however, I'll write that down right here. Right? Standard form is ax plus by is equal to c. And remember, a, b, and c have to be integers. And then remember, we have got x and y on the same side of the equal sign and our constant on the opposite. So when I look at standard form for x equals -2, well, that is in standard form, right? I've got my x's on one side of the equal sign and my constants on the other side, and I've got all integer values. If you prefer, we could write this as x plus 0y is equal to -2. Just don't have any y values, right? So the coefficient was 0 there. So this is in standard form. I can write this in standard form because this form is not dependent upon me writing a slope. So that's why this one works, but these two don't. In this problem, we want to write the equation of the line which passes through the point -2, 31 and has a slope of 0. And we want to write the equation of that line in 3 forms: point slope form, slope intercept form, and standard form. All right, so let's just sketch it out real quick first here. So we've got an x and a y axis. And -2, 31 might be somewhere up here. This is just a sketch. And then it has a slope of 0. So if it has a slope of 0, it means the line is flat. Okay, so there's no change in the y values. The y values here are staying constant at 31. The x values are changing, right? I've got change going when I plot points here. You can see they're at different x values, but all the y values are the same. They're at y equals 31. So that's actually the equation of this line, y equals 31. And again, I like to tell my students, I know that's a y equals because it cuts through the y-axis at 31. So that's the equation of that line. Let's see what happens when we put it in point slope form, slope intercept, and standard. So let's first talk about point slope form. Point slope form, that's y minus y1 is equal to m times x minus x1. All right, what's my slope here? I know my slope is 0. So this is going to be 0. And then my point is -2, 31. All right, so I know that each of those values are going to be substituted in. So point slope form is y minus 31 is equal to 0 times x minus -2. And you can go ahead and clean that up and write y minus 31 is equal to 0 times x plus 2. So this is the equation in point slope form, right? You can see the point, you can see the slope. Now let's write it in slope intercept form. So this one is y is equal to mx plus b, where m is your slope and b is the y-intercept here. Just write a little note here, slope, this is the y-intercept. All right, and let's look at our graph. The y-intercept is at 31, right? So we've got b here is 31. What else do we know? I know that my slope is 0. So we can finish this out. We get that y is equal to 0x plus 31. And you can clean that up just by writing y is equal to 31. Okay, the 0x shows me a little more clearly that the slope is 0, but because it's 0, we just don't have to write it. All right, so now in standard form, remember that's ax plus by is equal to c. So my x term and my y term are both on the same side of the equal sign. My constant term is on the other side. And then we also know that a, b, c are integers. Okay, so we can take this form right here and see what we get. So y equals 31. Do I need to manipulate it at all? I've got my y term. You can put an x term here if you want, 0x. Got those on the same side. 0 and the coefficient of 1 right here are both integers. The constant 31's on the other side. It's an integer, so yes, y equals 31 is also the equation of this line in standard form. In this problem, we want to determine, without the aid of a graphing calculator or any technology, the x and y intercepts for 5x minus 8y is equal to 13. All right, so let's just review a little bit. So an x-intercept is where the graph crosses the x-axis. All right, so if we draw it out right here, let me get a different marker. Over here, if we draw it out, here's an x-axis. Here's an x-axis. Here's a y-axis. So if I'm going to cross the x-axis right here, then I know for sure, I don't know what the x value is, but I do know that the y value there is going to be 0. Right? It doesn't have any height. That's not deviating from the x-axis above it or below it. It's on the x-axis. The y value there is 0. We can think of it similarly for a y-intercept, right? That might be up here somewhere. And on this one, we're not going to the right or the left from the axis at all. So what do we know about this one? We know that this has a value of x equal 0. So whenever I want to find the x-intercept, you're going to make y equal to 0. And then to find the y-intercept, we know that x has a value of 0 there. Okay, so in order to find the x and y intercepts for 5x minus 8y is equal to 13, to find the x-intercept, we're going to make y equal to 0. So we're going to say 5x minus 8 times 0 is equal to 13. That's just going to give me 0, so we get 5x is equal to 13. Divide both sides by 5, and we know that x is equal to 13 fifths. So this tells me then that the x-intercept, I'll write it as a point here, I'm going to go over 13 fifths on the x-axis and up 0 on the y, right? We put 0 in for y. So this is the x-intercept. To find my y-intercept, we make x 0. So we take this same equation, but I make x 0. So literally for that x, I put 0. So I get 5 times 0 minus 8y is equal to 13. This is just 0, that product. So I get negative 8y is equal to 13. So y is equal to negative 13/8. So to write it as an intercept, I need to write it as a point. And what did we know? Well, we knew that x was 0. So this first coordinate is 0. And then the y is negative 13/8. So that is the y-intercept. In this problem, we're given c is an integer, and we want to find the value of c so that the line given by 14x plus 8y is equal to c has an x-intercept of 4, 0. Okay, so if we have an x-intercept of 4, 0, remember this is going to be an x value on that line, and then this is going to be a y value on that line, right? That point is on the line. So I can take the 14x plus 8y is equal to some integer c, and I can substitute in these values then. So I can make x 4, and I can make y 0. That's going to equal c. So we get here 14 times 4, which is 56. 8 times 0 is 0. So we get here that c is 56. So c has to be 56 in order for that equation of the line to have a y-intercept of 4, 0. For this problem, without the use of technology, we want to graph this line that's given by y is equal to negative 3/5 times the quantity x minus 1 plus 4. So this is in a kind of a point slope form in a sense that I know this is going to be the slope of my line right here. And then I know that this is representing 1 point on the line here, this 1, 4. So I know that when x is equal to 1 and y here is equal to 4, that's going to be a point on this line. So I could write it as 1, 4. Okay, so I know that the point 1, 4 is on the line. I just picked that out from the equation that I have here, and then I know that my slope is a negative 3/5. So the first thing we want to do here is go ahead and graph this point 1, 4. So on this graph then, we're going to make this 1, and then this up here is 4. So each of these lines is worth a value of 1, basically. And now to have a slope of negative 3/5, remember for slope, this right here, the negative 3/5, this is telling me my change in y, and this is telling me my change in x. So this tells me I need to go down 3 units, right? So this right here, I'm going to go down 3. That's the negative 3 part. And then we're going to go over to the right 5, because it's a positive 5 change in the x value. So this one we're going to go right 5. And then we plot the point that is a result of that, the end of that there. And then we graph the line that goes through those 2 points. So this black line right here is the graph of y equals negative 3/5 times the quantity x minus 1 plus 4. In this problem, without the use of any technology, we want to graph this line y equals 5/2 x minus 3. So when I look at this, I can see that this is of the form y is equal to mx plus b. Okay, so the y is isolated, I have an x term, and then I have a constant term. So that tells me right here that 5/2 is my slope, and this negative 3 here is the y-intercept. So we know that the slope of this line, just from looking at the equation, is 5/2, and then we know that the y-intercept is negative 3, so I'm going to write that 0, negative 3. So when I graph a line, the first thing I need is the point, and then I use that point and execute the slope to find another point on that line and then construct the line. So here is my y-intercept, right? It's at negative 3 down here. I know that my slope is 5/2. So remember, this numerator tells you your change in y, and the denominator of your slope tells you the change in x. So since the change in y is 5, that means I've got to go up 5 units from this negative 3 here. So I'm going to go up 5. It's going to put me right here. And now I've got to go over to the right 2 because it's a positive 2. So I go over to the right 2. That puts me here. I go ahead and plot a point, and then I construct the line that goes through those 2 points, and that gives me the line then that represents y equals 5/2 x minus 3. In this problem, without the use of technology, we want to graph this line x equals 5. So what this means is that it's a line where every x value is 5. It's not dependent on the y value, right? The y value will change, but my x value has to remain constant at 5. So we go over here to where 5 is on the x's, right? And we can just plot any points, right? This point here has an x value of 5. It happens to have a y value of 1 in this instance. I can plot another point. This point here has an x value of 5, has a y value of 4. Here's another point, right? 5, 0. All three of those points so far have an x value of 5. Here's another one, has an x value of 5. Here's another one, has an x value of 5. So I can construct this line that goes vertically through 5, x equals 5, and this is a graph of the line x equals 5. All right, here we're given the line 5x minus 11y is equal to 2, and we need to determine that if x increases by 7 units, then what is the corresponding change in y? So we know that we have a line, right? So it's 5x minus 11y is equal to 2. This is in standard form. If I manipulate this equation and put it in slope-intercept form, I can find the slope, and then that's going to help me figure out what happens when if I change x, what the corresponding change is in y. So in order to put this in slope-intercept form, we need to isolate y. So the first thing I need to do then is subtract 5x from both sides. So that's going to give me negative 11y is equal to negative 5x plus 2. And then I need to divide everything by a negative 11 so that I have the y isolated. So y is equal to, I'll go ahead and write it this way, negative 5x over negative 11, or divided by, plus 2 divided by negative 11. And now I'm going to clean that up just a little bit and say this is y equals, a negative divided by a negative is a positive, so this is going to be 5/11 x. And then you've got a negative as a fraction here, so I'm going to write that as minus 2/11. Just a little bit cleaner. And I put the coefficient 5/11 in front of the x just so that I'm following the form y equals mx plus b. I can easily match up the m, the x, and the b. All right, so what does this tell me? This tells me that my slope here is 5/11, right? M is 5/11, so we'll make a note of that here. And remember, for slope, the numerator tells us the change in y, and the denominator here tells us the change in x. Always. So if I know that x increases by 7 units, that means that this change in the change in x here is 7, positive 7. So we can set up a proportion that says 5 is to 11 as, and you can put question mark here, right? That's what we're solving for. What would the change in y be if x increases by 7? So we would put positive 7 here. And now you can think that this is change in y, right? So I'm going to say 11 times delta y, which is change in y, is equal to 35. Divide by 11, so this tells me that the corresponding change in y is 35 over 11. So that tells me, since it's positive, the corresponding change in y is an increase, because it's positive, by 35/11. In this problem, we're given the line 5x minus 11y is equal to 2, and we want to know if y decreases by 32 units, what is the corresponding change in x? So when we do this, we want to be able to find the slope of this line. So the line is 5x minus 11y is equal to 2. And what I want to do is manipulate this so that it's in slope-intercept form, which is your y equals mx plus b, because I want to be able to easily identify the slope of this line in order to solve this problem. So to manipulate this, the first thing I want to do is subtract 5x from both sides. So I get negative 11y is equal to negative 5x plus 2. And then we divide by the negative 11 to isolate the y. So y is equal to negative 5x over negative 11 plus 2 divided by negative 11. And this cleans up a little bit better if we write it as 5/11 x minus 2/11. So the y-intercept is 2/11, actually negative 2/11. But for this problem, I just need to know that the slope right here is 5/11. Because what that tells me is that when we have a slope of 5/11, this tells me that when y changes by 5, the corresponding change in x is an increase of 11. So when y increases by 5, x increases by 11. In this problem, we want to know if y decreases by 32 units. So that means that the change in y is negative 32. So what we can do is set up a proportion and say that 5 is to 11 as, now we want to decrease y by 32. So that means the change in y would be negative 32, right? Because we're decreasing, that's where the negative's coming from. And we want to find the corresponding change in x. So now we can cross multiply, so I know that 5 times the change in x is equal to negative 32 times 11, which is 352, and it's negative. And then you divide by 5, so the change in x is negative 352 divided by 5. And let me check real quick here. I did this before. That division then is negative 70.4. Okay, so what does this mean? This means when you have a decrease in y by 32 units, you're going to have a corresponding decrease in x by 70.4. So let's write that out real quick. When y decreases by 32, there is a corresponding change in x by a decrease of 70.4 units. And I should probably put units right here too to be complete. So when y decreases by 32 units, there's a corresponding change in x by a decrease of 70.4 units.
All right, I hope you enjoyed that. Here's number 9. We're solving systems of equations. So let's go ahead and work through the first one. We're going to use the substitution technique, which is where we'll take, like in this case, negative 2x minus 9, which equals y, and substitute it into y for the other equation. So when we do that, we get 6x minus 5, and instead of y, we're going to replace that with negative 2x minus 9 equals negative 19. And then from here, we'll use the distributive property. We'll distribute negative 5, and then we'll combine like terms and use our properties of equality to get our solution. So distributing the negative 5 gives us 6x plus 10x. What would that be? Plus 45 equals negative 19. So combining the 10x and the 6x will give me 16x. From there, we will subtract 45 from both sides, and we'll get 16x equals, let's see, negative 19 minus 45. Negative 20 and 45 is going to be 65, and it's one less than that, so 64. So negative 64. Then we'll divide both sides by 16, so we get x equals negative 4. So we'll take that negative 4, which is going to be the x-coordinate of the solution, and we're going to substitute that in to the other equation, the one where y is isolated, so this one right here. To get the y value, we're going to get y equals negative 2 times negative 4 minus 9. So negative 2 times negative 4 is going to be positive 8, and 8 minus 9 is negative 1. So the coordinate where these two lines cross, which is going to represent the solution here, is going to be negative 4, comma, negative 1. So we want to write it as an ordered pair, negative 4, comma, negative 1. And there's the solution to 9a. Let's take a look at the next one. Let's examine 9b. Now for part B, this particular system, neither one of the equations has a variable isolated, so I'm going to try to isolate y in that second equation. So I'm just going to rewrite this, and I can do that by adding x to both sides, which will give me y equals x plus 1. So this is going to be the expression I use to substitute into the first equation. So I'll take this x plus 1, plug it in right there, and so now I can write this as x minus x plus 1 equals negative 2. So distributing that negative 1, we get x minus 1 equals negative 2. And then, okay, so look at here. So the x minus x is going to just cancel out, it'll be 0. And we're left with the statement negative 1 equals negative 2, which is obviously false, right? Negative 1 doesn't equal negative 2. And so what we discussed in the notes here is that when you get a false statement like this, whenever all the variables cancel out, you get a false equation, so this would actually not be true. You say there's no solution. So basically, that means there's going to be no coordinate where these two cross. The only way for that to happen is if they're parallel. So if you have two parallel lines, you're not going to have a point of intersection, so we say there's just no solution. Now, if this sort of thing happens and you end up with a true statement, like let's say it ended up being negative 1 equals negative 1, in that case you would say infinitely many solutions. So let's take a look at C, where we'll solve it very similarly here. We'll start by, we got to isolate y in one of these two equations. So I think the easiest one might be to isolate y in this second equation. All we would need to do is just divide both sides by 2. So that gives me y equals 2x plus 3. Then we could take that entire expression, the 2x plus 3, put it right there. So that's going to give me negative 2x plus 2x plus 3. And so we actually are going to get something similar to what we did in the last one, equals 3. The negative 2x plus 2x becomes 0. And so all we're left with is just 3 equals 3. So this is a little different here. All the variables cancel out, which is the same. But instead of getting a false statement, we are going to get a true statement. And just like what I tried to explain on the last one, when this happens, that means that these two lines are actually the same. They're lying right on top of each other, and so there are going to be infinitely many solutions. Doesn't mean every coordinate or every ordered pair is a solution. It just means that there are infinitely many of them. There'd be all the points that lie along that line that is represented by both of those equations. So that should be it. That's the last one on here. So as always, let me know if you have any questions. And other than that, y'all have a great day, and I'll see you next time.